So our next concept is percent composition. Percent composition is defined or equals part divided by the whole times 100%. And actually should say that 100% there. Okay, 100%. And the best way to look at this is to think of a pie. Let's draw a little pie here. Here's our pie. And let's make slices in the pie. Here's slice 1, slice 2, slice 3, and we'll leave the last slice to be a pretty big slice. Now, if the pie represents the whole pie, then what you're looking for is for each one of the pieces of the pie, what part of the whole pie does that piece take up? So here's our first piece of pie. We'll just call it just the red piece, right? And there's our red piece. And then we'll look at another piece here. Let's look at a blue piece. And here's a blue piece of pie, right? So each one of those are pieces of the pie, and they take up a certain amount of area of the pie, all right? The pie is considered the whole pie, the 100%, and then each one of those is a fraction of the pie, so you can look at it as the fraction of that part compared to the whole pie thing. Okay, so for an element and a compound, it's basically the same thing. It's just basically what fraction an element is in the total compound. And so the way to look at this in a more distinct way is the percent composition in a chemistry is equal to the partial mass of the element in the compound divided by the total molar mass of the compound times 100%. Okay, so we'll do an example of that in the next slide. Okay, here's our first example. What it's asking for: what is the percentage of mass of oxygen in the compound P2O5? And then we're going to also look for the percentage of phosphorus, right? So our first task is to get the total mass of P2O5, the molar mass of P2O5, and we've done that right here, right? So you know how to do that already, right? It's just the sum of all the phosphorus. So we have 2 phosphorus from here, and then we have 5 oxygen from here, and you multiply it by the atomic mass of each one of those, and you sum them up, and you get 142. Okay, so this is going to be our total mass of the compound, or the total part. All right, so we can erase this now. So let's erase this. All right, erase this. Okay, and now, so we do individual units. So here's our total mass. So that goes on the bottom of our fraction. And we know that we've already done this part here. That's our 80 grams of the part that the oxygen contributes, and that goes there. And then you multiply it by 100, and when you do that, you get 56%. Okay, and you can do vice versa with this, with the phosphorus. All right, you can do vice versa with the phosphorus. So here's our phosphorus. Again, we use their same total mass for the bottom, and then we use our phosphorus mass, total mass of the phosphorus in the compound here, and then we get 43.7%. So that's pretty much it for the first example. Let's look at one more example, and I think that you can get it with some work examples that you can do on your own. Okay, here's another example where we've worked out some things here. And so the first thing is we're asking for the percent composition of chromium in the barium chromate. And so here we go. First thing we need to do is calculate the molar mass of barium chromate. And we've done that down here, right? And so basically, again, you should know how to do this, but there's 1 barium, so that's 137. There's 1 chromium, and then there's 4 oxygen. And if you get the molar mass of each one of those contributions and then add them up, you get 253. So again, now 253 becomes our denominator in our percent equation, percent equation. And then since we're looking for chromium, we're going to use this value here in the top part. And when we do the math all together, you should get a C, 20.5%. All right, so there's nothing much more difficult than that. It's a pretty straightforward concept, and you should be able to do this now without any effort. Okay, just one more example just to make sure that everybody's on the same page. We're asking for, in this particular case, we're asking for the percent composition of nitrogen in the compound, this one here. And the only tricky thing on this one is to remember that we need to make sure we count all the nitrogens in the compound when we do our molar mass and when we do our percent nitrogen. So don't forget here that it's NH4,2, which is the ammonium ion, and we need to make sure that we multiply the 2 for this and the 2 for that. That goes in there. So, and when we do our molar mass, right, we need to make sure we have the 2 nitrogens and then the 8 hydrogens. Everything else looks pretty much standard. All right. So if we can do that, if you can understand how to do that and you know how to do that, this should be just as straightforward as before. So now we have got 28 for here, and our molar mass that we've calculated goes here, and you're all set. So you should get the answer of 21.2%. So again, the takeaway here is just to make sure you count the number of nitrogens and hydrogens inside the brackets and include them with your calculation. Okay, here's some practice problems that you can do on your own, and then I will come back when for the video and just write in the answers. But the bottom line is here is that the answers should be straightforward to you if you know how to do the other ones. I've given you a couple examples, some with brackets, some with not, some with multiple things in there. So if you can do this in the video exercise, you're fine, and then you should continue doing that with the worksheet that I've given you. Okay, I've written in the answers to the thing, and you should be able to do it from here. So if you haven't got these answers, you should re-practice and look at them, and if not, you can find me and we can work on doing it together.